Hello guys, so can you hear me and see the screen? Just confirm once so that you can start. Hope so the voice and screen is clearly visible. So yeah, we'll just wait for a few minutes, more minutes, and then let's start with our session. So yeah, maybe I think we should start. So in the last session, as we know, we stuck around with this question. So we haven't found any answer and we just got stuck. So we weren't getting a correct answer. So there was a test case which was given, which gave us the wrong answer. So here is the same test case. So this was giving us some wrong answer. So it hadn't had duplicates, but still, what was happening? So what can we do is we will basically debug this code. So let me just go to this window again. And here, what we can see is, let me just, before returning something, as we were printing and debugging, we will do the same thing again. So what I do is, yeah, so basically what we were doing is calculating the sum from 0 to k. Okay, so using this simple formula n into n plus 1 by 2. Then we were calculating an index which would consider how many next values to be considered after this k. So then we had a dictionary in which we stored which all numbers we have got, and is this do if we get them again, then we were not going means we were not doing this thing. So we were not subtracting, because if duplicate elements exist, then we don't have to consider this again. So here what we basically want to see is where are we getting the main error. So what I do is I create a new list. So let me create a new list, so called as k underscore list, which contains all the values which we have considered for the k. So what will I do? I will start with all the elements from 1 to k. So for x in range 1 to k plus 1, because it stops at one value before the k. Uh, so here I will get all the values from 1 to k, and then what will I do? Whenever I subtract a number, I will remove this. So I will remove this from the key list. So key list dot remove uh, remove the num, and after adding k plus index, I will add that into the key list too. So basically I am creating a list of values which we are using as the summation, so that we can confirm whether it is working correct or not. So k plus index. Yeah, so at last, before printing this thing, let's just print the k underscore list. So k underscore list, and let's just give some this input. So test case would be something different. So this would be the test case, and let's just run the code again. So it takes a bit of time, but yeah. So here we can see this is the output. So this has the thing which this is the array which we are considering for the summation. This is the k array. which contains the 76 numbers, as k is given 76. We require output as 3444, but we are getting 3423. So what is basically happening here is, so here as I can see, in this value 83 is present, but here also 83 is present, so this is giving wrong. We need unique values. So why is this happening? So whenever we loop through these elements, so let's say my current key, let me just take these values. Yeah. So here were the two elements. Let's just take some random elements. It has 83, and this list also had, this was the key list which has 76 elements. It also had the 83. So why was this happening? So as we can see here in the code itself, so here we can see is we are just checking number is less than k, and we are directly appending k plus index, so we are not checking anything. So here let me just show this. So this is the nums array, and this is our new k array. So what is happening is, so let's say I have added 0 to k was 76, so I have added 0 to 76 in the at first. Just a second. So I have added 0 to 76. Then what happens? I get some values. I remove that values from here. In between, I get some values. I remove and I add 77, 78, 79, 80, 81, 82, 83, 84. So let's assume I am adding this much values. So what happens here? Some values are deducted, and similarly, simultaneously, other elements are added. So we are directly using index and we are checking. So here what happens? This 83 is present in the list, but we aren't checking this. Why? We are directly appending k plus sum, sorry, k plus index. So I'm directly using k plus index as the sum value. So here what happens is, I am adding the non-unique elements too. So this 83 isn't unique, but still I am adding. So similarly, I will be also adding some other values. Currently I can see 83 only, but there are other values too. So here if we see, there would be more values too, but we have to search for that. So 83, 88, 88 would be also there. So you can see 88, 88 is repeating. So what should we do here is, so basically, if we somehow try to manage this, we check for the elements too. So one approach would be to check if index plus k is means present in list or not, or do that thing. So let's just try that too. So after removing from the list, while the k plus index is okay, we have to check in the dictionary. So d dot get k plus index. If k plus index is not equal to none, not equal to none means it is not giving none, then what we have to do is, then we have to do this. So we have to increment index. Okay, this is at last. So we have to go on incrementing index until we find an perfect index, which with adding with k doesn't give us none. So we will be computing, we will get some value, and we will then add that to index and do this thing. So let's just run this code again and see what happens. So then this d of num, so then this d of num we are updating afterwards after appending. So what happens is, here we have to also add this means basically new element may be added. So the numbers we aren't checking, that too may get. So instead of doing this, what will I do is, let me just explain what I want to say is. So basically I have I will take some random example, not from this. So yes, I have this. So I'm currently at this position. Okay, so my d value has currently this one value and one is present. I'm just assuming one is present. Now somehow my list is 0 to 7 and I am trying to add 8 element to this. I'm removing 1 from this and I'm adding 8. So till now I will check whether this dictionary has 8 or not. So it the dictionary doesn't have 8. So we will directly add this 8 and it will become 078. And then what will this happen? After performing 2, 3 and 8, we will say that 8 is not present. Why? Because we will then mark this as present. Until then, what will happen if 2 and 3 is present? Then we will go 9 and 10. So here again, we are not going to check for 8. So this is kind of an issue. So basically, uh, I what the solution or approach says that is, why don't we sort everything? So if this list is sorted, so 1, 2, 5, 8, 10, then 2. So if this happens, what is happening is basically if 2 is we are accessing 2 after performing this greater elements, we are facing some issues. So what if we sort? So 1, 2, 2, 5, 8 and 10. So what will this do? First of all the smaller values will be removed and we don't need to think about greater values. So like this we have to sort. So we will remodify code a bit. So yeah. Let's just start from this thing, scratch itself. So sum of k would be 0 to summation of 0 to k. Okay, that would be the summation. Then we would try for let's say instead of taking index, what we can do is, as we are adding index to the k and repeating the k again and again, what we can do is we can use a next k. So next underscore k, and which we can assign to k plus 1. So currently up to k all the values are considered, and the next k is this thing, k plus 1. So instead of index, what we will do is we will directly add that value. So after that, what I have to do is basically now, so up till now I have this list. So here I can say I have this list, all the elements of this list, and I have 0 to k, summation of 0 to k. Okay, so I have this. Now let's assume I have 5, 10, 20 and 10 again and 30. So basically we have to sort this at first. I will sort this and it will give 5, 10, 10, 20, 30. So this will become sorted. Now we will do all of our compilation on this sorted array. So let me just move this a bit. Also this. So now what will I do is basically now I will check for 5. If 5 is 5 present here in this 0 to k. So let's take k as 9. So if k is 9, so we have 0 to 9 addition. And if 5 is present, so what we'll do? If 5 is present, if 5 is present between this thing, we will remove 5, means we will subtract 5 and add next element, which is 9 plus 1, 10. So this is the next key. So we are adding the next key. We are removing the current element and we are adding the next key. Now our list becomes 0 to 10. Okay, so 5 is removed and now our list becomes 0 to 10, means the addition of all the elements minus 5. Okay, so now our new value is changed. So here we know if anything is less than 10, then we have to remove that because 10 is also now included. So if I now check for 10, what will happen is, okay, sorry, not that list. So this sorted list. So if I now check for 10, so if it is present, so means basically it is there in this list. So what will we do? We will remove 10, add next of k. Means if we were adding 10 at last, now we will add 11. Okay, so basically now what will happen? This will again modify 0, all the elements. 5 is not included, 10 is not included, and we have add 11, and here minus 5 minus 10. So basically this will continue on and we will go on subtracting and adding the values, and at last we will get this value. So this was the basic approach. So as you can see, this seems very simple when we know the solution, but for finding this, it's a bit complex. I too took so much time, so I was unable to find out this in the last lecture, in the last session. Basically, this is the beauty of the medium level problems. So these look simple, but while we work on that, it is kind of complex. So now what we have to do is we have to basically sort the list and then apply the for loop. So I will just use nums equal to sorted num. So this will, or I can directly use an list method which is sort, which will sort that nums list. Okay. So what will I do for let's say num in nums. So now this nums is sorted. So what will I do is if this num is less than here we saw we have to check for the newest this thing. So here it should be less than or equal to, or what we can say is it should be less than this thing because this is one value ahead. So if this is 9, this would be 10. If this is 10, this is 11. This is 11, this is 12 here. So something like that. So what we can do is we can modify this a bit and say if num is less than next x. So if it is less than next x, what will we do? We will remove means we will subtract that. So sum underscore k minus num. Okay, so minus equals, and then we will add our next element. So sum underscore k plus equals next k. So we will also add the next k, and what will we do is we will increment the next k. So next k plus equals 1. So at last, after looping through all of these values, this would become fine, and we have to return sum underscore k. So let's just run this code and check whether it is working fine or not. So here this value is also now accepted. So 3444 is now coming. So let's just try submitting this. So still wrong answer. Maybe there is something left. Okay, so here we didn't manage the case that we may have a duplicate numbers. So yeah, let me just see. This list may contain some duplicate element. We have to basically search. So for removing duplicate element, what we can do is we can use that dictionary method. So first of all, we have to compute that. So let's take t equal to this thing, and for num in nums, basically going through each value, what will I do is d dot, sorry, if d dot get, we are getting num. So if d dot get gives me a none, means it is not present. So then what will I do is I will add that value. So d of num equal to 1. If this is not the case, then what will I do is basically have to check here. So basically now what I have to do is I have to basically reduce duplicates. So what I can do is I can check for each num if it is already exist or not, or what I can do is I can only loop through this key elements. Means here if there are duplicate numbers. So basically let me just explain this. So here what will happen is d will consist of all the numbers 1 1, 2 is present, yes, 3 is present, yes, 15 is present, yes. So basically if I somehow get all of these keys and I will loop through only this, so my duplication will be resolved. So the same thing we can do with this set also. So if we can convert list into set, what will we do? Duplicate elements will be removed. So similarly, let's just do what we can do is instead of performing on nums, we can do, we will first use list and d dot keys. So we will perform on d dot keys. So let's just run this code. Let's just execute this and then try to submit. So this works on this. So this should probably work now. Yeah. So this basically got accepted at last after 1, 2, 3, 4, 5. 5 submissions we got accepted. So this was the thing how we can do this. So this was kind of a median problem. If this seemed a bit confusing, then you can ignore this a bit for now, because I too took time, and yeah, it was a bit complex question. So like this, similarly, you can see the code. You have to just convert this same thing into C++ code. So what you have to, instead of dictionary, you have to use map, and using map, you have to do the same thing. So hope so you will do the same, or if you want, I will perform this quickly. So C++, and this sum would be long, as they have already mentioned, they require the sum in long. So long sum, this will be performed, this will be performed. Then next k would be an int. Let's take that too as a long, or maybe it would be an integer. No, it would be long. Let's just take this. Then there isn't anything that nums.sort in Python, sorry, in C++ sort, and we have to give the nums dot begin, and then nums dot end. We have to use this sorting technique. Then instead of d, what we have to use is map. So the first value would be integer, and the second value would also be an integer. So map this, and we will take, let's take d. Okay, so maybe there aren't any method called as get. It should be something like let me just check. So how to check if any element is present in the C++ map or not. So maybe it's find or something, uh, not array. Check if it is present or not. So like this, you can find any method if you know there is something. But you, okay, so m dot find key, if it is equal to m, means not present. Yeah, so it was find. So yeah, just a second. Yeah, here for nums in nums, same thing can be written in for loop also, but the nums would be some data type. So it would be integer. Basically for num in, maybe it's colon. Yeah, for int num in nums, we can perform this thing. Uh, let's just do this. Paste it here, and if, so instead of get, we have to provide a parenthesis. Let us remove this. So if d dot find, so if we find this number, so if it is equal to d dot end, means that element is not present. So what we will do is we will insert an element d dot num equal to 1, and similarly after doing this, what we can do is we can, so how would we take the elements of the key? Maybe we could start from, oh yeah, so what we can do here is we could take an auto. So auto means any data type it can accept, and auto, it basically gives a pair. So map returns a pair of two elements which we used here, int and int. So auto pair, and we will iterate through d. So what we will do is we will basically check if, so if the num, where is the num? Okay, not the num, it should be pair. So pair, if pair is less than next k, so next k, yeah, so then some k plus minus pair dot first, maybe, yeah, it should be pair dot first, because pair would have two values. So pair dot first, if pair dot first is less than this thing, so we have to use a parenthesis, then curly brackets, then move this a bit. Take this below, add semicolon, semicolon, and semicolon. Basically, uh, there isn't any formatter. I have to manually do this thing. So this and next k plus equals 1, or we can also put plus plus and some plus equals next. Yeah, this things seems right. So some k this and minus. Okay, so let's just try and run this code. Maybe there isn't any error. Hope so. There shouldn't be any. Okay, so next key. They don't know what is next key. Okay, there is double key. Shouldn't be double. Be single. Return doesn't have a semicolon, and this should successfully work. See, we haven't changed any logic, so this should work. There is some syntax error only. So other things remains the same. This should just get okay. So overflow, something we took as integer just got overflow. Maybe this should be auto, and here that's line number 4. Okay, so this thing. Instead of int, what we can do is we can take long, because values we are getting is long. So here also long, and we are getting this, and let's just run this code again and submit it. Maybe this should work now because we have converted everything into higher data type. Still, there is some integer. Uh, this value can be represented in type int. Which value are we trying? This is long. Okay. So this into this cannot be represented in type int. Okay. So we have to multiply it by 1 ll. 1 ll maybe. Yeah. But this should now preferably work. I don't know. Is it small or big? Maybe capital L. So it has been a long time. I haven't tried coding in C++, so this may happen. Still, there is some issue. 1 ll. So k into k plus 1. So one long. Maybe yeah, this should work. So what is happening is this cannot be represented. Okay, unbehavior. Is it 1 ll or one long? I don't think this should be correct. So there is some way we convert. Let me just check. So we have to check. Basically, check is how to use uh, long in conversion of C++. So LL. Okay, so we have to use LL, capital LL. This should work. Why isn't it working? Yeah, let me just check. So here 1 ll. First of all, I will multiply this and then this. Yeah, this worked now. So basically it was trying to multiply k into k plus 1, which both are integers and were giving out a overflow. So now this works, and this was the basic question, medium level question of how to append k values. So now let's just see one more question, which is from the lead code itself. Just a second, just search for the problem. This is the easy level problem which we can perform. So this is a basic question which you can also read. So if you have any doubts, you can post that in comment section. I will just check that out. But till then, you can read this question. So which app are you talking about? Instinct N. Sorry, I was busy with the code itself, so I was unable to see. If you could say, can we open in web if app doesn't work, if app doesn't have web version? Which app? It depends which app are you talking about. So for now, let's just see this question. So maybe there isn't anything and you all are good with this thing. So the basic question is square root of x. As per seeing this, I am getting that there should be something related to finding square root of x. So here, given a non-negative integer x, compute and return the square root of x. Okay. Since the return type is an integer, the decimal digits are truncated, means they are removed, and only integer part of the result is returned. So maybe if you are calculating for 3, so 3 is somewhere around 1.73 something something. So you have to only return 1. Note, you are not allowed to use any inbuilt exponent function or operator such as power or x raised to something. This used in Python. So you are not allowed to use that. So we have to find some value. Okay. So how do you think we can do this? So basically think a bit how we can find a thing, and we will also discuss it. So yeah, just think if there is some number 3, how can we find 3? What is the square root of 3? If I have 4, I know it is something 2 into 2. So basically two integers, when they multiply, they will give this thing. So here I will write on 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. So how can we find depending on these values or any other value? If you want to repeat, the question is we have to find a integer square root, and so we have to find a square root of an value, and we want it in integer. We would not consider any decimal part, we only need this in integer. So pause the video, think a bit, and yeah, so pause if you want to think more. I will start with the solution. So here, let's take some random example: 3, 8, 15, 25, and 69. So I want to find out numbers of this. So here, if I'm finding for 3, it is somewhere around 1.73. I know that, but how will I found using computer? So I know 1 square is 1 and 2 square is 4. So it should lie between something this. So 1 and 4, it should lie between 1 and 4. So if we take 2, so 2, what would 2 do is, it would return 4. So we want lesser. So in between this 1 and 2 means 1 point something. So if something is neglected, what is the answer? So we need 1. Okay. So this is the answer for this 3, which is 1. Similarly for 8, I know it would be somewhere between 4 and 9. Okay. So here I know the lower bound is 2, means the lower value is 2. So it will be something 2 point something. Similarly for 15, it is between 9 and 16. It will be 3 point something. So we return 3. If it is between 20, it is 25. I directly know it is 5. If it is 69, then it is between 64 and 81. Means it is, means the square root, integer square root is 8 point something. So like this we can find. So, but how do we find this square itself? So how do computer know this thing? So here I know one thing, that if I start from 1 up to let's say 3, so what I can do is, if I am finding for 1 to 3, what I can do is, let me just shift this a bit. Just change the color to, yeah. So if I am finding for 3, I can go from 1 to 3. I can check 1 square is what. So 1 square is 1. 2 square is what? 2 into 2, 4. So then 3 square is 3 into, okay. So we will only say up to 4, because 4 is greater than 3. So if this square becomes greater than 3, we will take the previous value. Simple as that. Let's just take another example. Let's take for 69. So I am finding the square root for 69. I will start from 1 to 69. I don't know. It may be between, means it may be n by 2, it may be greater than n by 2, or anything can happen. So what I will do is, I will check 1 into 1. Okay, not possible. 2 into 2. 1 into 1 is 4. 2 into 2 is, sorry, 1 into 1 is 1. 2 into 2 is 4. 3 into 3 is 9. 4 into 4 is 16. 5 into 5 is 25, 6 into 6 is 36, 7 into 7 is 49, 8 into 8 is 64, 9 into 9 is 81. So 81 is greater than 69. So what will we do? We will take this previous value, which is 8. So basically we have to use a for loop and compute the things. So this is the simple, very much simple thing. So let's just try this. So if you want any specific this thing, you can put a message on the live chat at which programming language you need. So maybe so there is C++ at start, so we can start with that. So I have an x, I have to return the integer part. So what can I do is, I can start with a for loop for int I is equal to 1. We will start with 1 because our value may be 1. It is 0. So if it is 0, so if it is 0, x is equal to 0, return 0, because we can't perform anything. Else what we have to do is, we have to start for loop from for int int I equal to 0, sorry, I equal to 1, I is less than, so it would be always less than x, I plus plus, and what will we do is check if, let's just compute the square, so square I sqi equal to, so this should be maybe the value is between 2 raised to 31 minus 1, so 2 raised to 31, let's just compute, so this is somewhere around 2 raised to 31 minus 1, so it is unit 10, okay, this is 2 digit, 4 digit, 6 7 8 9 10, so integer range is 10 raised to 9, so this won't store, so we have to use long long, so we will use long long. Okay, so we will use long long, and then what will we do is, why are we using long long? Because we are multiplying two integers, so this should also be stored in so this will be stored in integer. X is an integer basically, but the multiplication can go beyond integer. So here what we will do is I into I into I, so this gives me square. So basically now I have square. I will check if square of I is less than, sorry, is greater than, so if it is greater than this current value, which is x, if it is greater than this, what will I do is I will return I minus 1. So getting basically, why will I return I minus 1? Because this is greater and I want the previous value. So I is sequentially increasing. If it is 1, 2, 3, 4, 5, and if I got that 5 is not the value, then it would be 4. So this should work. Let's just try. It's taking a time. Non-void function returns a value. Okay, which value? Does not return value in every case, so it isn't returning after if else is not executed. So we will here return minus 1, means the answer is wrong, or we can't say, so this condition won't be met, but still, so here we can see 4 and we are getting 2. Let's just submit and see what happens. Wrong answer, so input 1 and 1 square is 1, so expected 1. Okay, we have to also add one new case, that else if, so else if, or what we can do is we can modify this thing itself. It is, if it is 0 or 1, so if it is x is equal to 0 or x is equal to 1, return x. So for 2 and thing, this should work fine. So these are the edge cases which they consider while, okay, so for 2 I am getting y, so here I am starting from 1, so 1 square is 1, which is not greater than, then if I check, okay, 1 square is not greater than, then it would go I plus plus, so then it will be 2, 2 is less than, okay, this should be maybe equal to also. So now if we submit, so because 2 is not less than 2, but 2 may be answer. Yeah, we are doing the same thing, last case 1 ll, this should now work. Value is going beyond integer this time. So now you can see this question is now selected, this question is successfully submitted. So this was the basic code which we were doing. So more good approach, so like this now get selected, but if the values were bigger and we have to complete more thing, we can use binary search. So binary search can also be used to do this thing, but maybe we won't consider this now, because yeah, maybe we should go to Python, and if time persists, what we will do, we will see the binary implementation too. For now, let's just do this thing. So I'm getting x is an integer, so same thing, for I in range 1 to what, maybe 1 to uh, x plus 1. So we'll go from this range if yeah, before this we have to put the case if x is equal to 0 or x is equal to 1. The same case which we put there, return x. Else what we have to do, we will automatically see this thing. So this else will automatically happen if this condition is false. So what we will do is for I in range 1 to x plus 1, if I into I is greater than x. If it is greater than x, what we will do is we will return return I minus 1. So this should work. Let's just test. So yeah, this works. Let's just submit. Let's see whether this works with the submission or not, or it takes more time. So for I in range, what has happened? Memory error. Okay, so this okay, last input, this value is too much big. So what we can do is maybe we could convert this into integer, but integer would also work fine. Let's see what happens. Let's submit and see. Still my square, what is happening is parameter 1, memory error. So there is some memory error in x plus 1. So maybe x plus 1 is greater than integer capability. So what we can do is we can either try, we can use a try catch block, or what you think is if some number is near about this. So if also if x is equal to, this is kind of an very wrong practice to add this for a simple code. If x is greater than 2 1 4 7 9 9 9 9 9 9, so I will reduce some value. So x minus equals, let's just say 10,000. Yeah, maybe this should work because it is near about, it is bit greater than n by 2. Still x minus equals this thing. Let's just add two zeros more and submit. So 1 2 3 4 5 6 7 8 9 10. So let me just reduce this much value. Okay, so what is happening? Maybe i's value go beyond this. So if x is last executed input, so if this is the input is changing basically. Yeah, I know. We have taken something else. So Python error. And let's see the details. First, this thing should work because why isn't it memory? But this is a bit bigger number maybe. So for this, let me just think how we can solve this. So return solution dot my squared parameter 1. So they are providing some value, and where are we getting memory error is for I in range. So maybe range can't be this much big. So what we can do is if x is greater than int dot max, is there something that such as let's just take to just copy this. So if it is something greater than this, we will put x is equal to the greatest value here. 1, 2, 3, 4, 5, 6, 7, 8, and 8. Yeah. Maybe we could copy this value and test this. Run code. The time limit exceeded. That took long time. So here we can implement the binary search as we discussed. What we can do is, instead of looping through all these numbers, let's just quickly implement a binary search. So before implementing binary search, I would give a basic idea how this works if somebody doesn't know. If you know, then it is well and good. You can just recap your revision and things. So binary search will always take a sorted list. So let's say 1, 2, 3, 4, 5, 6, 7, 9. Okay. So this is something. So let's say I am searching for some random value 7. So what can I do is, I can directly go to middle element. I can check 7 is greater than 5 or less than 5. So here, as I know, everything is in sorted order. So if 7 comes, 7 will be always after 5. Why? Because in sorted sequence, means in the sequence ascending order, we know always 5 comes before 7. So what I can do is, I can discard all of these half elements and I can search for these 3 elements. So then again I will find a mid. So after finding mid, I will get that number. I will check, yes, it is correct. So we got just 2 checks. Similarly, if there is some similar thing, binary works similarly. So 23, 25, 38, 92, 100 and 11, etc. So I'm searching for 29. So what will happen? I will go to center. So it should be less than this. So this is discarded. We don't need anymore. Then we will check between this. Let's just say this is the this thing, the middle element. Then this two will be discarded, and now we can't find any value because it isn't present. So like this we can reduce the search space by directly half. So this has a time complexity of log n. If you want to detailedly discuss, if you want to learn more about this, there is a full dedicated video called as sort. So also I have taken a question and I have explained that, so you can view that. So here what we will do is basically implement binary search. So let's just return, let's just implement binary search. So we need 2 values. So lower would be, let's say, 1, and we will start from 1, and higher would be something x. So let's just take this, and then while, so while L is less than H, so lower should be always less than H. Until that we will calculate a mid. So mid equal to L plus H divided by 2. Basically this should be the mid. And then what I can do is, if mid, so if mid is greater than X, so as we saw, if mid is greater than X, then our lower value changes. So here as we saw, so let me just take the same example. So here, if I have 1, 3, 5, 7, 9, and I am checking if mid is greater than, so mid, let's say 5 is greater than the X. So if 5 is greater than the X, let's say 2, so we are searching for 2, but middle is greater than this thing. So what will I do is, I will remove all of this thing. So my height will be reduced. Sorry, the higher value will be mid minus 1. So here higher value H is equal to H, mid minus 1. So mid minus 1. So directly half of the search space is neglected. Then else if, so yeah. So here what we have to check is, first of all we have to check if med is our current value. So this would be elif, this would also be elif. But if this mid into mid is let's say greater than, if this mid into mid, or let's say this value, so what we can do is, if mid into mid, what we are checking is if that middle element is greater than this thing. So basically let me just put this. So what we are basically checking is if we are searching for 2, oh sorry, so here we will be searching for this thing. So 1, we will have 1 2 3 4 5 6 7 8 9, like this we will have a value. So I have to search for 8, square root of 8. So what will I do? I will set this as L, this as H. Okay, so then I will find a mod. So 8 plus 1 9, 9 by 2 would be 4.5. So I will take integer, which is 4. So I have to also take integer here also. So floor division, yeah. So like this I will get 4 as a mid. So after getting 4 as a mid, what will I do is I will check. So what I have to check is square root of 8. Okay, so I will check 4 into 4 is 16. So 4 into 4 is 16, and 16 is greater than 8. So what will happen? These values won't be considered. We have to check between these three. So what will I do is I will reduce this to half. Similarly, then I will so this is how we neglect this half elements, and we will check between this. So now I have 3 elements, so I will check for 2. So is 2 into 2 greater than 8? So is 2 into 2, sorry, 2 into 2 is 4. So if 4 is greater than 8, this is not the case, then what we will do is we will reduce this lower part. So what will we do? We will, so this may be an answer because it is lower than this. So this may be an answer. We can't directly neglect. Why? Because if we go to 3 plus 1, 4, 4 plus, if we go to 3, so let's check if we neglect what happens. So we remove these two elements and we check for 3. So 3 is the only element. What will we do is 3 into 3 would be 9, and we will check is 9 greater than 8. So 9 is greater than 8. So this shouldn't be a value. The value beside this should be a value. So how would we know either this is the thing or that is the thing? So what will we do is instead of neglecting this 1 and 2, we will just neglect 1 and say 2 may be a value. Oh, sorry. So 2, if this is smaller, if this is smaller, then this may be a value. So what will we do? We will then check between these two. So let's say 3 plus 2 is 5, 5 divided by 2 is 2. So again this thing. So yeah, this should give me 2. So let me just do it again. So 2, and then what will we do? We will be getting this 2 plus 3. 2 plus 3 is 5, 5 by 2 is 2. So 2 square is 4. Again checking this. So yeah, we have to somehow do this. So maybe if we are checking for some element, so as we can't directly find, what was I thinking is if we have any number, let's say 4. So what we can do is we can do 2 check. But which check should we do? So we can do 4, and 4 plus 1 5. So 4 into 4 is 16, which is greater than 8, and 5 into 5 is also greater than 8. So like this we can let me just think what could be a value. Or what can happen is, in this cases what we can do is we can implement a modified version of this. So instead of this arrows means, if if here we have 2, here we have 3, so like this, if we have two pointers and we have to check which of them is a suitable answer, what we can do is, instead of putting while L minus H condition, what we can do is we can put sorry, L is less than H condition. So instead of putting this, what we can do is L minus H, sorry, H minus L is equal to 1. So if this is not okay, not equal to, if this is greater than 1, while this is greater than 1, we will do this. If it becomes less than 1, means we have two values. Now from the two values we have to check. So what we can do is we can go back here, instead of doing this check. So what will we do is H minus L is greater than 1. So H minus H means the difference should be greater than 1. It shouldn't be 1. So like this we can check. So then again we can check is if mid into mid is this thing or not. So here what will happen, we neglect this. If it is greater than, then what we do is let me just reframe this. So if the mid value, mid into mid, is greater than the current x. So if mid into mid is greater than, means 4 into 4 is greater than this, we have to neglect that. But if mid into mid is less than x, means it may be a possible answer. It may be. So we don't know. It may. And if mid into mid is mid into mid gives us x, then mid is the answer. So we can print this. So if mid into mid is equal to, what we can do is yeah, let's just do this. Mid into mid is equal to x. We will return x. Sorry, return mid. If mid is greater than, so not the mid into mid. So we are basically checking the square. So if mid into mid is greater than x, means we have to neglect that mid. So we are reducing that. Else if what, or we can directly put else what we have to do is L is equal to mid. So mid may be a possible answer. We can't take mid plus 1. And then yeah, so after completing this while loop, if we didn't return here, what will we do is we will check if uh, h sorry, yeah, h into h means it would be a value. So here, as we saw, at last, if we came to this condition, that what may happen is this would be our lower value, this would be our higher value. So we'll first check if higher value is the answer or not, because it may be answer. Because if this is the answer, L will automatically become the answer, because both are lesser than this thing value. So what we will do is we will check if h into h is greater than uh, if h into h is let's say less than this thing, uh, if h into h is, what we can say, if h into h is greater than x, means it is not a possible problem. So return L. Else if else what we can do is, else we can return h. So mostly this should work. Let's just see what happens here. Yeah, this is accepted. Let's just submit and see. This should work fine. This should I check accept. Yeah, it is accepted, and 84.46% faster. So yeah, this is one of the solution which we can implement because of that memory issue. Because we are multiplying things, we are multiplying and doing the things. You can directly use binary search, and this makes the calculation easier. So yeah, maybe this would be all for these two lectures. If you have any question, you can put that in comment section. If you don't have anything, we can stop here. So this would be all for today's lecture. Let's meet with new questions in our next session. I will just wait for 2-3 minutes more if you want to ask any doubts or not. If you don't have any doubts, we can end. So currently there is no live viewer. So maybe I think I should change this a bit. So coming live, and if you are giving no responses means if this doesn't see if I'm not getting any responses, then what is the meaning of taking the live lectures? Because live lectures are taken so that you can directly communicate, and if you have any doubts, you can ask and do some things. Currently, no viewers, and for the whole session, last session too, there weren't any viewers. So maybe what I think is I will continue this sessions, but maybe instead of directly using this easy questions and things, I will work more on my side. So instead of coming live and solving these questions, what will I do? I will learn new things. I will try to solve medium level questions on my side. And for this time, as I have said, I will do coding every day, and I will upload something every day. So what I will do is I will create recorded videos of my playlist which is struck. So I have basically left that playlist incomplete to continue with these sessions, so that you some viewers will be there. But yeah, it thinks I seems that I should put those videos continuously, because that may help other people a lot. And we will continue this live sessions on Sunday. So on Sunday, we will continue with this live sessions where I will solve some questions. And from Monday to Saturday, what will I do is I will put on the videos for the playlist, which DSA playlist, the SPPU TSL playlist. I will keep on putting videos and premiering it at the 9 p.m. So this won't affect a bit. I won't be coming live. I will just start premiering the video, and we could work like that. If you have any doubts or any questions, maybe you can put it in comments. If there aren't, we can stop here. So this would be a bit change. I will try to upload recorded videos from tomorrow at 9 p.m. and that too will be related to questions itself. I will be continuing the playlist, SPPU DSL playlist. And for coming lives for solving these sessions, maybe no one is enjoying this much. So what I can do is I can only come at weekends when I will be free, or sometime when most of the user can join. Mostly it's weekend, I think. So we can take live sessions that time. So yeah, that's all for this video. Is there anything anyone wants to say? I will just wait for 5 more minutes. If anyone wants to say anything, then I will wait. If nobody has nothing, then we can just stop. So thank you guys. Thanks for joining. And this would be all for today. From tomorrow, we will meet the new questions and new approaches. Thank you. Thanks for joining.